This video covers section 12.1, Distance and Midpoint Formulas. Objective 1, use the distance formula. We learned how to plot points in chapter 3. In this section, we look at how to find the distance between 2 points. We will then have a connection between geometry, measuring the distance, and algebra. We can find this by using the Pythagorean Theorem. Remembering that the Pythagorean Theorem works if you have a right triangle. When you have a right triangle, you have your legs, A and B, and you have your hypotenuse, C. And the relationship between these three is A squared plus B squared is C squared. So these are going to be numbers. A is going to be the length of this side, B is going to be the length of this side, and C will be the length of the hypotenuse. So to find the distance between these 2 points, we'll plot them, we'll form the right triangle, and we'll measure the lengths of our 2 sides, and then use the Pythagorean theorem to find the length of the hypotenuse. The skills needed to achieve this are going to be simplifying a square root. Square root 4 times square root 6, which is 2 square root 6. Simplifying a square root where we have the square root of the sum of 2 things squared. 4 minus 9 is negative 5, and 7 minus 3 is 4. That's 25 plus 16, which is 41. 41 is prime. It has no perfect square factors, so we leave it that way. Now again, we're finding distance between 2 points. And so to find the distance between 2 numbers on a number line between negative 4 and 5, remember there's a 0 in between those. So the distance is always the larger one minus the smaller one. And there's 9 units separating those two. 5 minus and minus 4 is 9. Whereas if it's the distance between 3 and x, we would say that distance is then x minus 3. So if we want to know the distance between these 2 points, 2, 4, and 5, 8, we form the right triangle between these 2 points. We've got the hypotenuse, we've got the side and the other side. To find the distance between these 2 points, we call it D for distance. We need to know the lengths of its 2 legs, and we see from 2 to 5, x equals 2 to x equals 5. That's a distance of 3 because it's 5 minus 2. And this distance from 4 to 8 is 8 minus 4, which is 4. So our triangle has an A value of 3, a B value of 4, and we want to know what the distance is. So the Pythagorean theorem says that A squared plus B squared is C squared, but in this case we're using D for distance. So we have 3 squared plus 4 squared equals the distance squared, or the distance would be the square root of 3 squared plus 4 squared. That distance is square root of 9 plus 16, or the square root of 25, which is 5. So the distance between these 2 points is 5. Now this was a nice example where we got a nice answer out of this, Doesn't always happen. Here's a practice problem for you to try. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. We form the right triangle between these 2 points. That's one side, and here's the other side. And so from -2 over to 4, that side has a distance of 4 minus -2, which is 6. From -1 up to 3, that side has a distance of 3 minus -1, which is 4. So our right triangle has an A value of 6, a B value of 4, and we want to know what the distance is between these. So Pythagorean Theorem says A squared plus B squared is C squared or D squared, and gives us 6 squared plus 4 squared equals D squared. So that says D is the square root of 6 squared plus 4 squared, which is 36 plus 16, which is 52. So the square root of 52, and 52 is 4 times 13. So this gives us a distance of 2 square root of 13. Now, these two problems were nice and easy for the Pythagorean theorem to be used because the grids were given, the coordinate plane was given, and the points were plotted for us. And so if that's not the case, if we just want to find the distance between 2 points and we don't want to have to draw the coordinate plane, we want a formula for this. And so what we were doing was we were saying that the distance between 2 points squared was A squared plus B squared. The A was this leg, which we took the larger x minus the smaller x, x2 minus x1. And so that was our A value. Our B value is the larger y2 minus the smaller y1. We added those up, we squared them, added them up, and then to get D, we had to take the square root of that. And so that's our distance formula. Now you'll remember these x2 minus x1 and y2 minus y1 as rise and run. So we're still doing those same things. And since we're squaring them, the nice thing is the order doesn't matter. So the distance between any 2 points is x2 minus x1 plus y2 minus y1 squared and square root of that. 0 minus 3 is -3, but we're squaring that, so the order doesn't matter. 3 minus 0, 0 minus 3, squared, both gives us 9. 4 minus 8 is -4, squared is 16. D is equal to the square root of 9 plus 16, which is the square root of 25, or in this case, the distance is 5. Here's a practice problem for you to try. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. Our distance formula is y2 minus, or sorry, let's start with the x's first. 4 minus x2 minus x1, 4 minus a minus 2. Plus y2 minus y1. 4 minus a minus 2 is 6. 7 minus a minus 5 is 12. And that's 36 plus 144. And so our distance is the square root of 180. 180 is 36 times 5. And so that gives us 6 square root of 5. Practice 3. I'll work this one out with you. Consider the 3 points A, which is negative 1, 1. B, which is 2, negative 2. And C, which is 3, 5. A, B, and C. Now we want to find the length of each side. Let's start with AB. AB, we take negative, 2 minus a minus 1 squared plus negative 2 minus 1 squared and the square root of that. 2 minus minus 1 is 3, squared is 9. Negative 2 minus 1 is negative 3 squared, which is 9. So the square root of 9 plus 9 is the square root of 18, which is 3 radical 2. Now let's find AC. A and C, 3 minus a minus 1 for the x's squared. 5 minus 1 for the y's. Square root of that. Three minus minus 1 is 4 squared. 5 minus 1 is 4 squared. That gives us the square root of 16 plus 16, which is the square root of 32, which is 4 radical 2. Now we'll find the length of BC. BC, 3 minus 2 squared plus 5 minus a minus 2 squared, and the square root of that. 3 minus 2 is 1. 5 minus a minus 2 is 7. That's the square root of 1 plus 49, or the square root of 50, which is 25 times 2, or 5 root 2. The triangle we drew looks like it's a right triangle. To verify that, we verify that a squared plus b squared is c squared. Any triangle is a right triangle if it satisfies the Pythagorean theorem. So that's the length of AB squared plus the length of AC squared should equal the length of our hypotenuse, which is BC. And it's easier to use these numbers when squaring these. So AB had a length of square root of 18. AC had a length of square root of 32. And BC had a length of 50. Square root of 50. And when you square those, the square roots go away and you have 18 plus 32 equals 50. Yes, it is a right triangle. And to find the area of the triangle, we know the area of a triangle is 1/2 its base times its height. So if we look at this triangle from the base side of AB and the height of the side AC, AB had a length of 3 square root of 2, and AC had a length of 4 square root of 2. So the base is 3 radical 2 and the height is 4 radical 2, giving us an area of 1/2 the base 3 radical 2 times the height of 4 radical 2. 3 radical 2 times 4 radical 2 is 12 square root of 4. And radical 4, or square root of 4, is 2 times 12 is 24, divided by 2 is 12. So we would say 12 square units. The area is 12 square units, whatever we're measuring the units in. And this concludes the video for section 12.1, Distance and Midpoint Formulas. Objective 1, use the distance formula.